Welcome back. At this point, you should have investigated the Desmos sliders that helped you investigate A, H, and K, which are all parameters of our quadratic function. So I'm going to kind of sum up what you should have seen, and I highly encourage you to take notes if you haven't already or if you're struggling with this. Also, I'm going to be showing you on my graph what is happening here when we make these shifts, so drawing some sketches would help as well. So the first thing you investigated was the parameter A. This is the number out in front. As you can see on my graph here, I have the parent function, y equals x squared, graphed. Now our parent function is the most basic parabola from which all of our transformations will be generated. So this is our parent function. I put the point -2, 4 on here. It's in black. I did that so that we can see what happens when I make some changes specifically. So on the side here, you can see anytime you have a number 0 to 1, so basically a fraction or a decimal in front, so as your A value, this will compress the function. And when I think of compress, I think make smaller, right? And so it makes sense that by plugging a smaller number, like a fraction in front, will compress. So let's look here. I'm going to put on here the graph of 1/4 x squared. So let's look at where this compression happens. I'm going to put another point here. So basically our point that was -2, 4 has been compressed. My y distance has been shortened. So now I have the point -2, 1. So my y value was 4. And then now I'm taking 1/4 of that, which makes it smaller here. If you look at the distance from my point to the x-axis, I have this long distance here. And when I multiplied by 1/4, I compressed it. So now my distance is only from this red point to the x-axis. So you can see how it was made shorter. So 0 to 1, basically fractions and decimals as our A value, will compress the function. I'm going to take this graph off, and we are going to look at the opposite end. So if I have a value greater than 1, this will stretch the function. So let's take a look here. I'm going to use a value of 2. So now my point here of -2, 4 has now stretched up to the point -2, 8. So again, if I'm thinking about the distance from the point to the x-axis, I have now stretched it so that point is much longer. And again, I think too, stretching, something's getting bigger. The distance is getting bigger. So if I multiply by a number bigger than 1, my graph should stretch and get bigger. Lastly, we're going to look at what happens when we put a negative number in front of my x squared, or we have a negative A value. Okay, a negative A value will reflect across the x-axis. So as you can see here, my point of -2, 4 has now become -2, -4. It has just reflected across my x-axis. So this all has to deal with our A parameter. Now I want to take a look at our H and K. Again, I have my parent function here, y equals x squared. And I am going to look at what happens when I subtract in regards to my H value. H is inside the parentheses. So when I have subtraction, this shifts my graph to the right. Subtraction moves it right. Then addition will move my graph left. So it's kind of the backwards of what you would think. So when we are working inside the parentheses, it is the opposite. Okay, so instead of moving left, subtraction actually moves right. Addition moves left. Okay, so lastly, I want to look at our K values. So let me add here. So if I have y equals x squared, that's my parent function, and I subtract a number, my graph will move down. So subtracting in the K area or outside the squared will move our graph down. So we can just about guess what will happen if I turn this to addition. Let me add an expression in here. Y equals x squared plus a number, it moves up. So addition in the k value or outside the squared will move our graph up. And those are the key transformations that we have worked with so far.